My name is Itamar. I lead BigData Boutique. We have been active in the space of search and big data for a while, and now also AI. So we used to say that search was never cool. Now it's cool and nobody calls it search. It's just AI. And that's what we do. And I'm here today to talk about the consolidation of search and AI, and basically on agentic search or agentic RAG, if you will, and how that comes together. I will cover some stuff that may be considered as basics. So based on the notes of the people present here, I'll be able to adjust speed. So if I'm kind of moving too fast, just let me know, because I would maybe consider some stuff obvious. A little bit about myself. So I've been doing this for over 15 years at this point. Started with Lucene Java. I've been doing this also on the .NET space for a while. It's been a while since I did .NET. I've been part of the PMC. It's not really alive, I guess, at this point. It's very old versions, but there's still software running on Lucene.NET. And then Lucene.NET, I saw this space of search servers kind of coming to life. Back in the day was called Compass, and then it became Elasticsearch, and then nowadays we have OpenSearch, which we'll talk a little bit about that. It's a fork of Elasticsearch 7.10, and then taking its own path from there. I'm an OpenSearch ambassador since about 6 months ago. It's a title from the Linux Foundation, the OpenSearch Software Foundation, that has been given to me and some 15 others, I think, at this point. We are maintainers for the project. We are also focused on the ops side of Elasticsearch and OpenSearch as well. We're maintaining the OpenSearch Kubernetes operator. So anyone running OpenSearch self-managed on Kubernetes, there's plenty of those. We basically support those. I'm acting as a CTO and founder of BigData Boutique, and we have also created Pulse, which also supports OpenSearch. It's effectively an AI DBA, so to speak, for ClickHouse, Elasticsearch, OpenSearch, and Postgres coming up. So that's a little bit about myself and what we do. And what I want to do today is to talk a little bit about some of search basics. Again, moving fast through those, and then connect that to what is agentic search, why do we need it, how it works, and what to look for. So let's start with this slide. Effectively, it would have been a very weird world today if you would have searched for a small lion and got this kind of result, right? Because the word lions, right, capitalized, lowercase, whatever, does exist in those words. So if you would have done just keyword search, you probably have found it, right? And it would probably be scored high if you think about Ben 25, because lion is less frequent than small in many cases. But that's not the right answer to what you were searching. And then, the real answer you're going to get from any search engine nowadays would look something more like this, right? Even if you didn't use the right word, like a baby lion or a cub or whatever, then you would still find that, because semantically they're the same vector space, to continue on Carly's session and so on. So that's what we actually see today, right? We're able to do that, and we've been doing this with vectors most of the time. I'll cover some additional options in a second. Same thing for when you search, you're actually not going to get textual results necessarily, right? So there is some level of intent understanding in pretty much any search engine that we use today. And sometimes it goes without saying. We don't even notice that, but it actually happens, because the word red doesn't appear in many of the results that you'll search when you search for address. So how come it knows about that, even, especially in e-commerce and retail websites? So we'll discuss that a little bit as well. Same thing for more complex queries like cheap laptop. So laptop could be a computer, could be other words. That's fine. I mean, this is still semantic, but what is cheap? Cheap would never be in the terms. it would basically be left to you to infer what needs to be done, right? Probably sorting by price or putting some price limit or based on the available prices and so on. So it starts to be very, very sophisticated. Now, we as humans, we want good search to happen, right? We want our users that when they search, that they find what they want. But it becomes ever more important now when agents perform the searches. So this is what I'm trying to cover here today. Basically, the landscape of what's commodity or what's close to be commodity for everybody to use right now, and then tailor that into agentic search operations. Similarly, I'll also touch on this example in a second. Again, when you actually do semantic search, there are a lot of times that we're fixing because of the semantic search, the vector space and so on, we're fixing spelling mistakes, spelling errors, grammar mistakes, and so on. But we also need to be cautious not to do that too aggressively, right? So Violet with a double T, for example, is an actual movie and an actual product, and there is a meaning to it, even though somebody could have just typed T twice. So it's the way to understand what a person is actually searching. And I did use Google and Amazon as examples here because it's pretty much what we are used to without even noticing. So vector search, again, I'm not going to cover. We consider that as basic nowadays, and then also Carly did that. I would mention though that in many cases, when we work with customers, the scale of the search, think about the knowledge base of a company. It's not hitting even not millions of vectors, and in many cases, ANN, BBQ, all of those are not even necessary. So you can just do KNN, exact KNN, however it's called, or brute force vector searches, a lot of names for that. So the vector search that you do can actually be very simple and very stupid, and it's just going to work well. And when we do talk about vectors, we actually do need to differentiate between sparse and dense. Sparse vectors is actually what have been doing for, I don't know, over 15 years now. BM25, TF-IDF, all of that is a sparse vector, and that's obviously we all here know what it is about, and it's not semantic, right? It's exact. But there are some sparse vectors worth knowing about, just in case someone in the audience is not aware of that. And one of those examples is Splay. Those are like very thin models, very easy to work with, very cheap models that can actually get you some additional words and a rank for that, even though they're not in the original text. So that is the reason why we would go for sparse vectors a lot of times is for speed, for compute power, and so on. And that's actually working pretty nice in many situations. So worth knowing about that. And then dense vectors, which are really semantically rich. There are plenty of those. A lot of times we actually use coherent embed It's very, very impressive in a lot of situations, and obviously all of the quantization, compaction methods apply for pretty much any vector, especially vector spaces with higher dimensions. So that I would assume as a given and something that's already known. On the RAG use case, which is what I wanted to talk about today, is one of the primary use cases that we see in many cases. And then because also it's very cool today. And in that use case, again, going very quickly around that, we're going to get some documents. We're going to ingest them into some sort of an index or a search engine, and then we're going to pass them through an embedding model. Again, it can be sparse, it can be dense, it can be multiple, and then get them into the vector database, whichever that may be. When we do a retrieval, we're going to do some pre-processing one way or another. So maybe cleaning stuff up, maybe enriching. We'll go through that in a second. And then pushing that again to the same embedding model to get back a vector that we can query. The G in RAG implies what happens with those results. Do we show the results or do we generate something? So like a textual result. So it's really a matter of implementation. sometimes re-ranking, and so on. This is a very basic, stupid RAG, right? And by stupid, I mean it's just too simplistic. And that's what everybody has been doing once RAG has been, conceived or maybe made popular and some sort of a commodity. And very quickly saw all of the limits that this structure, this architecture has. Mostly, it's a single step. So if you did the search correctly, you'll get good results. If not, then not. You're very much dependent on the actual query processing and what the user was querying for. So you'd actually find places where people were asking, so like back in the day when you would search for something, you'd get bad results, you'd refine the query, and you still need to refine queries also with RAGs, which I think is kind of misses the point. What you don't see in the graph here is the hybrid search approach, which again, many people just went and did vector search, it would just work, or just did keyword search and lost the semantic meaning. And then hybrid search starts to complicate things, as we'll see in a bit, but it does need to be added here. And then intent understanding, which is, the part of the examples I gave in the beginning. When someone searches for something, it doesn't necessarily mean that the vector or the keywords are going to include some of the nouns or anything else that has been used. So this is the problem statement that I want us to discuss. OpenSearch has been forked from Elasticsearch a few years back. I think it's 4 years at this point. It's 100% open source. A lot of features that are being developed in other places are going to be brought into OpenSearch, but kept completely open source. There are notable OpenSearch Foundation members, AWS, to mention one, which are this is the company that actually forked OpenSearch. OpenSearch was under AWS for a while. Now it's under the OpenSearch Foundation, Software Foundation, which is effectively the Linux Foundation. It's a sub-organization over there. And then you have Uber, you have IBM, you have many other software giants that support and actively maintain it. It's vector search ready, AI ready. We'll talk about what that means. There is a rich ecosystem and tools, and it's also being used very frequently as a monitoring tool, monitoring solution in many places. So like many of you know Kibana, which obviously comes from Elasticsearch, then there's OpenSearch dashboards. There's a lot of monitoring use cases over there. So it's kind of nice to have one technology that can do both, right? Both the vector search, hybrid search RAG, and also the monitoring piece of it and tracing. And it's obviously well understood and supported, deriving from the Elasticsearch roots. And there's a lot of managed solutions for that, managed options, which is also nice. Several vendors that take different approaches there. Just one example for the things that you can do with OpenSearch, there is something that's called a neural query, which is basically zero effort to get just a hybrid search or a semantic search with a model that's baked into OpenSearch. It's just there for you, and it's quite nice. I know Elastic has that as well. I think it's called Ezra or Ezra. I'm always confused, but those are the built-in features, which is pretty nice to have within the engine. So let's go back to talk a little bit about search and the RAG or agentic search that we want to cover. Keyword search, which is what we've been doing for a while, it is a very well understood problem, but it has a lot of limitations, right? The terms have to appear, or we have to maintain synonym lists. We can do a show of hands how many of you maintain synonym lists for a while and how annoying it is. You don't have to do that anymore with vectors, obviously, but keyword search still has that kind of limitation. There's no semantic understanding, obviously. There's some scoring challenges. BM25 fixes some of it, but not all the time. And then obviously we don't know what agents or AI is going to ask our search engine. And this is the biggest challenge with keyword search. So if you want to make your data accessible to agents, you really have to be able to support semantic searches because you don't know what what keywords the agent is going to use. So that's why when we talk about semantic search, we obviously throw in vectors into it. But then when we have vectors, we go into the precision and recall problem, which is how do I know that the search results that I get are actually precise, but also have good recall. So semantic search vectors will help me to get recall up, but naturally precision is going to drop because suddenly I have a lot of results that are not as interesting. Or remember the violet case, right? I search for something specific, but then the vectors overcorrected my query. So we need to fix that. That's what brings us to hybrid search. Up until this point, I kind of expect everything to be known. And now this is the place where maybe we're starting to talk about new stuff. So hybrid search combines keyword and vector search together. And the best way to do that is with RRF, reciprocal rank fusion, which effectively executes two different queries with two different scoring systems. One is the keyword search scoring system, BM25, and so on. One is the vector search, which is, has multiple distance calculations, let's assume Euclidean, and then merges them together, which is non-obvious. Okay, so it's not obvious on how to do that, but RF is a formula which I'm not a mathematician, but what it does with some very good and sane defaults is actually able to take those two very different scoring systems, combine them together, and get you a very well sorted score result set, which will favor results that are ranking super high in one, so they're not overshadowed by the other. And that's practically how it's working, and it's given literally for free in OpenSearch, and it's working pretty well. So hybrid search is effectively doing both and enjoying both of two worlds, and getting to a very good and balanced precision recall balance with RF. So any search that you're going to do, assuming it uses RF, it's just one step of the way. What usually happens, and I don't think I'm going to exaggerate if I'm going to say it's like 60, 70% of cases, the searches you're going to get from users and especially from agents is going to contain terms or phrases in the search query that are not going to be useful as a semantic or keyword search phrases. So I'm going to search for a cheap laptop. I'm not going to get that in the actual text. I need to fix that somehow. And this is metadata filters or metadata boosts or metadata rankings or anything like that we do need to apply. And this starts to get into the intent understanding and query parsing that we're going to touch on in a bit. But think about pretty much anything on the range of filtering or boosting by a label, category, location, source, any numeric value, and so on. So that's like strong filters or sometimes even boosts. And that when you combine this with hybrid search, it actually can get you a very powerful place. And that's what gives us the query intent, right? So coming back to the cheap laptop example, you'll be able to take the cheap laptop, pass that through some query intent understanding process. We'll talk about that in a second. And then derive that the search phrase needs to be laptop. And then cheap is actually not a search phrase, so it's not going to be sent to the search engine at all. And therefore, it's not going to spoil the search results, but it is going to be applied as some sort of a filter or ranking or negative boost to the search. So that's something to consider. The way that we do it, or one of the ways to do it, is through some keyword extraction. And really the best way to do that, I believe, is with LLMs nowadays. So no regexes or anything like that. Just take the text, pass this through to an LLM, let the LLM categorize based on your schema, based on whatever is going on, and generate the phrases and also the metadata filters and so on, and then send that to the search engine. One of the additional things we can do with it is obviously some additional business signals and boosting. Some can be derived from the query itself, but some can be just be baked in and then obviously injected, like time decay, prioritizing by search, by number of likes, by number of purchases, and so on. So this is the function square queries, or however they're called nowadays. Anyone here familiar with Hive? Okay, so this is the first time I heard of it. I was quite surprised, and it's I think it's simple is genius because it's so simple. The concept is someone searches for something. Let's ask a stupid LLM. It doesn't need to be costly. It doesn't need to have knowledge or anything like that. Let's ask a stupid LLM, a small one, a very cheap one. What would be an answer? What would an answer look like? Even if it's not, even if it's completely wrong, it will still contain some words that we will explain to have in the a resulting document, in the actual result. It's probably not going to be the right result. Sometimes it will, but I don't care because what I got from the LLM is going to be my query, my semantic search query, maybe even keywords, hybrid, to my engine. And it works surprisingly well. So it's also a method to use. Most of the time, it's usable for knowledge-based queries, right? Not necessarily for e-commerce, but more of knowledge bases, chatbots, support agents, and so on. So that's a method that I think definitely worth mentioning in this context. We have a blog about synonym expansion with LLM that we used for image search. So there's a lot of ways to do image search, right? But I think this one demonstrates a way to do feature extraction from text, right? So someone asks for something and we execute that against images, and the images are tagged with some text. And we do have some issue with single word queries against, again, tagged data sets, but that also use very short context or single words on the metadata. And given that challenge, LLM can actually do that quite nicely. So we work a lot with AWS. This specific project was done with AWS, and we used Claude. Look at the version of Claude. I mean, we've done it a long time ago. So Claude version 2. And basically look at the prompt. So I want to act as expert product analyst. Given this query that the user asked us, what would be some additional synonyms that we can use, right? So suddenly, and this is didn't even use vectors on the search query. We just executed keyword searches, and it worked well because the LLM expanded the synonyms for us. I think this is still applicable today, especially in the query intent and query understanding phases. But that's like worked really well for us back when the models were very, very stupid. I mean, look at the date of this blog. I think it was like 23, 24, something like that. If I would have done something like that today, it would look more like this, right? So someone searches for a red dress. I would ask the model to emit not an OpenSearch query, not a full-blown query, but a schema of what phrases I need to search for, one or more, what categories, given the categories that I have, needs to be either eliminated or included or filtered for, and any sorting or anything like that. So given the schema that I have for my retail or my e-commerce or my knowledge base, I would I would get a JSON back from the model and then obviously structure the query based on that with tenant filtering and so on. Another thing worth mentioning, I'm not going to go into a lot of detail. Probably Alessandro and team has tons of experience around that, is re-ranking. So effectively, when you actually execute a query against Elasticsearch, OpenSearch, whatever, you're going to get back results. But those results probably need to be re-ranked based on something, right? On models, on LLM judging, or on anything of that sort. There's quite a few options. Linear rank, I think, is pretty much the industry standard nowadays. If we need it, we're going to talk about that in a second. But re-rank is also something to consider, and it's also part of the puzzle for that. And now we get to talk about agentic search and what it is, right? So the whole point of search is to be able to serve the user with what they were searching for. Back in the day, we were very sensitive to latencies of searches. Now, my assumption is that very high percentage of searches are actually done by agents. And when you are a user sitting down and working with some sort of an agent, so when you sit down with Claude Code, you don't really expect it to return fast. You understand that it does the way that you call it thinking. So you're okay with that. That's why the searches that we do don't necessarily have to be very, very fast. Obviously, any step that would be faster would be nice, but searches can actually be iterative now. They now want, everybody talks about loops now. That's pretty much what's happening here and what agentic search is all about. So when a user submits a query, you do have some query planner to build. And that query planner is basically your query intent understanding code, which can probably use or should use an LLM. And that decomposes whatever the user was searching, maybe expanding on the phrases to search for, execute hybrid search for each, applying filters, applying boosts, and so on, and passing that through RF. So RF will basically merge everything in together. You now get a full set of results, and potentially, I don't know if it's necessary, but potentially you can do a re-ranking based on any business logic or anything of that sort. And at that point, you want an agent again, trained agent with good prompt, maybe with some few short examples to look at the question, look at the top answers and decide whether or not we got enough answers. Maybe it will do some sort of oversampling, as Colin called it. It will run yet another search just to be sure, changing maybe a couple of things. But models today are pretty smart and are able to, in this stage, and here you do need a smart LLM, they can kind of understand if the question was completely answered to full satisfaction, or maybe can be tweaked a little bit. Then if it decides that we do need some refinement, you're going to refine and execute the flow again, obviously with some limit on the number of iterations. And only then you can either display the answers or generate an answer. And that's what we call agentic search. This word is moving very, very fast, but I believe what you're looking at right now is a very, very proven architecture. It is something that actually working well. It could change, but I think it's something that can definitely be implemented today and used as is, and sustain some good long run. All right, so this is what we call the extract then retrieve loop. And again, the word loop here is maybe key. There is tool usage. So the only tool you need here is knowledge-based search, but maybe in your business, there are other stuff that you can do. Maybe there is a tool that can get weights. Maybe there is a tool that can add some additional information based on user preferences, organization, tenant preferences, and so on. We'll talk about that in a second as well. Using OpenSearch and knowledge base for sure, for search, obviously, any engine with keyword search and vector search, providing RF as well, would be interesting here. And then the LLM, you need to pick the right LLM, otherwise costs will go out of control. And every step of the way here, you can use different LLMs with different costs. Usually we see that the query planner can be a very cheap one. And then even push back on queries that don't make sense. So we have that. And there's also prompt caching that you should definitely use in many of those cases. Obviously, guardrails, protecting, because once you go agentic, you need to protect yourself. And reason about search results is both here, but also keep everything aside for evaluation. When we do talk about agentic, we also need to talk about memory patterns. People talk about agents and sometimes don't even think about memories. And then when somebody mentions the memory, then suddenly, they kind of tend to confuse a lot of things. I think it's worth to split that into two different discussions. One is the short-term memory, which is basically the memory about the session, right? Those things usually take turns. especially in chatbots. Somebody asks something, gets a response back. There has been search involved, and then now you ask about it again. Maybe that's your way to refine the search or to dive deeper. You need to remember that. Sometimes it's remembered as turns, as full turns, just last few turns maybe, or sometimes it's summarized, compaction, as they often call it. And then there's the long-term memory. Long-term memory includes the key knowledge base itself, and also any user or organization preferences, learned behaviors, any kind of rules as part of the guardrails or anything beyond, and then any feedback loops that you might have in your organization. So click streams on e-commerce is very interesting. If there is any spike of purchasing, any specific product you want that factored in, any discounts, anything like that, that would also be interesting. And those are long terms. The interesting part is, I think OpenSearch, and some might disagree here, but I think OpenSearch is great in all of those types of memories. So key value storage, I don't know, DynamoDB, Redis, Aerospike, many others might be very good for key values and others. OpenSearch can actually be quite good at that as well, while also including versioning. So it's not the best tool for the job, but you can actually have everything built on OpenSearch, which is interesting. Same thing for evaluation and during relevance. Like I mentioned, OpenSearch has a lot of capabilities around login analytics and so on, and it can be used as well to remember the traces of OpenTelemetry and so on. So basically for everything for debug and evaluations later. And also to accumulate judgment lists, to measure that, to run evaluations, to see how things are going, and so on. On evaluation, just a couple of words about that. There is a lot of people talking about LLM as a judge. Yeah, so what we see is that it's costly at scale, right? But also it's very bad at telling you what is right, what is wrong. It's much better not bad, but it's not that good. It's much better in getting you in seeing two results and then telling you which one is better. So we often use LLM as a judge to differentiate between two possible answers and deciding which one is answering better. We see better results there. But our thing is how can we get more feedback or more inputs other than LM as a judge? So maybe finding ways to trigger people to click on the thumbs up, thumbs down. Nobody clicks it, and if they click the down, right? So maybe finding ways to get positive feedback as well. Looking at click streams. I think crowdsourcing is still a thing sometimes on that. So in large scale, we can get crowdsourcing helpful as well. And then the human evaluation is actually analysts, not just many people, but actually the quality of judgments. So that's that. OpenSearch also has the relevance workbench contributed by open source connections, and it's usable. It's nice. It's relatively new, but it's definitely something worth paying attention to. And also very new, I haven't even used it yet, is Agent Health. So again, baked into OpenSearch, you now have the ability to monitor agents and measure their performance in across various metrics. And so various agent runs and see how they're doing. So again, having that, again, I don't think OpenSearch is the best tool for evaluation. There's other tools that are meant for that, Opeak and Langfuse and others, but it's definitely nice to have everything in just one place and start there and then evolve from there. So that I don't need to touch on. Carl has been much better than whatever I'm going to tell around that. We do have a blog about scanning vector search. Obviously, we talk about all the basics, right? So using few dimensions, quantization techniques, and so on. Carl covered that much better than I will. And to monitor OpenSearch or get OpenSearch done and optimize in production, we actually have a video series where I go through that in detail. So actually looking at very tons of items and what to look for, thread pools and sizing and so on. And it's up on YouTube, so feel free to go and watch that. There's also the Twitter handle for me here, so you can reach out to me over there. I think there is a QR code as well in the end. So just to summarize everything we went through, I think 2026 is the year where people wrote almost no code, like the general population of engineers stopped writing code, but also at some point are going to stop searching for stuff and actually speaking to LLMs and agents to execute searches for them. And we need to be prepared for that. And that's why we need to stop using keyword search and actually starting to use to build for searches that are more complex. And for that, we need to have better query understanding and so on. So using vectors, using hybrid search and RF, and doing a lot of query intent understanding, but then also making sure that everything that is evaluated and monitored closely. And that's basically my message to you here today. We do have a kind of a walkthrough tutorial for starting with, in this case, vector search, but hybrid search is a quick follow-up from there. And thank you for your time and for your hospitality. And if there's any questions, happy to take them.